A recent video published by the Russian Ministry of Defense, the Tu-43 Malva, a 152mm wheeled self-propelled howitzer developed by Russia, has been deployed in the ongoing conflict in Ukraine. The first confirmed sighting of the system occurred on June 2, 2024, when aerial imagery revealed the Malva in a firing position in the Kharkiv region. This marks the first operational use of the upgraded Tu-43 Malva and highlights its advanced features, including electronic warfare systems, anti-drone protection, and a newly developed long-range shell capable of firing up to 50 kilometers. The deployment signifies a major step in Russia's efforts to enhance its artillery capabilities and adapt to the demands of modern warfare. The Tu-43 Malva represents a significant advancement in Russian artillery technology. Its development began in the late 2010s under the Nabursock program, aimed at creating a wheeled artillery platform that prioritizes mobility and operational efficiency. The system is built on the BAZ 6610-02 Vashina 8x8 wheeled chassis, produced by the Bryansk automobile plant, offering increased mobility and reduced operational costs compared to traditional tracked artillery systems. This wheeled configuration allows the Malva to achieve faster road speeds, greater fuel efficiency, and easier maintenance, making it particularly effective in dynamic and fluid combat scenarios. State trials for the Malva were completed on May 17, 2023, confirming its compliance with tactical and technical standards required for deployment. The first batch of Malvas was delivered to the Russian Armed Forces on October 26, 2023, with a second batch reportedly delivered in June 2024. Deliveries have continued since July 2024. Russia plans to produce approximately 400 units of the Tu-43 Malva, although the exact number currently in active service remains undisclosed. The latest version of the Malva addresses criticisms of earlier models, particularly concerning its firing range and operational effectiveness. This upgraded version replaces the older Tu-64 cannon with a modified artillery gun, likely derived from the Tu-36 Howitzer B system. This modification allows the Malva to achieve a maximum firing range of 50 km using newly developed long-range shells, a substantial improvement over previous iterations. The system also supports Krasnopolem precision-guided munitions, enabling accurate strikes against high-value targets at extended distances. These advancements align the Malva's capabilities with some of the most advanced Western systems, such as the French Caesar and the German PZH 2000. The Tu-43 Malva incorporates advanced defensive features to enhance survivability on the modern battlefield. Electronic warfare (EW) systems are integrated to counter drones and electronic surveillance threats, while anti-drone shields and a camouflage net improve its defenses against reconnaissance and drone-launched strikes. Although the Malva's wheeled design sacrifices heavy physical armor compared to tracked systems like the Tu-19 STS, its reliance on modern electronic countermeasures and mobility compensates for this limitation, reflecting a forward-thinking approach to artillery design. When compared to other self-propelled howitzers in Russian service, the new Tu-43 Malva demonstrates clear advancements in protection, firepower, and mobility. Unlike older systems such as the Tu-19 STS, Tu-1 Vozdika, and Tu-3 Akatsia, which lack integrated EW systems and modern anti-drone measures, the Malva is better equipped to handle the challenges of contemporary warfare. Its 50-kilometer range far surpasses the 30 kilometers of the Tu-19 and the 15 to 18 kilometers of the Tu-1 and Tu-3. While the Tu-7 Pion, with its 203mm gun, achieves ranges up to 55 kilometers, it lacks the precision-guided capabilities of the Malva, making it less versatile in certain combat scenarios. The Malva's mobility is another key advantage. Its wheeled 8x8 platform provides faster deployment and repositioning compared to tracked platforms, which are slower, less fuel-efficient, and require more maintenance. While systems like the Tu-19 and Tu-7 perform better in rugged, off-road environments, their slower speeds and higher logistical demands limit their adaptability in fast-paced operations. The Tu-43 Malva offers several distinct advantages over both the French Caesar and the Swedish Archer, particularly in terms of firepower, electronic warfare capabilities, and mobility in modern combat environments. One of the most notable advantages of the Malva is its extended firing range. With a maximum range of 50 kilometers using newly developed shells and the precision-guided Krasnopol M munitions, the Malva offers a substantial edge over the Caesar, which has a range of 40 kilometers with standard shells and 55 kilometers with extended-range rounds. While the Archer also shares a comparable range, up to 50 kilometers, the Malva's emphasis on long-range firepower, combined with modern precision munitions, gives it a distinct capability in terms of striking targets at extended distances with a higher degree of accuracy. Additionally, the Tu-43 Malva integrates advanced electronic warfare (EW) systems that enhance its survivability and effectiveness in today's highly digitized and contested battlefields. These EW systems are specifically designed to counter drones, jammers, and electronic interference, providing the Malva with superior protection against aerial threats. The incorporation of anti-drone shields and camouflage nets further increases the system's ability to operate undetected and reduce vulnerabilities to enemy surveillance. While the Caesar and Archer are both equipped with modern communication and targeting systems, neither offers the same level of integrated protection against UAVs and electronic threats as the Malva, which is particularly important in modern artillery engagements where drones play an increasingly dominant role. Finally, the Tu-43 Malva's wheeled chassis provides significant advantages in terms of mobility. The 8x8 wheeled configuration allows for faster redeployment and more efficient logistics, enabling the Malva to rapidly traverse roads and highways with ease. The Caesar, while also wheeled on a 6x6 chassis, offers slightly less mobility and adaptability compared to the Malva, particularly on rough terrain. The Archer, with its tracked chassis, excels in off-road conditions but suffers from slower road mobility and greater logistical complexity. The Malva's faster road speeds and better fuel efficiency make it particularly suited for operations requiring quick repositioning and rapid strikes, a key advantage in dynamic, fast-moving conflict zones. In summary, the Tu-43 Malva's longer firing range, advanced electronic warfare capabilities, and superior road mobility give it clear advantages over the French Caesar and Swedish Archer, particularly in environments where modern technology, including drones and precision-guided munitions, plays a central role in combat strategy. These features position the Malva as a highly effective self-propelled howitzer in contemporary warfare, especially in terms of operational flexibility and response time. The deployment of the Tu-43 Malva in Ukraine reflects a strategic shift in Russia's artillery doctrine. By combining long-range precision firepower, advanced protective measures, and high mobility, the Malva addresses the challenges posed by modern warfare, including the increasing role of drones and electronic countermeasures. This deployment marks a significant step in Russia's ongoing efforts to modernize its military capabilities, providing a versatile and technologically advanced artillery platform to support its operations on the battlefield. Thanks for watching.